Focus on the point estimation. That is an essential component of confidence interval estimation. This I'm illustrating how confidence interval estimation connects population parameter with sample statistics. We are interested in learning the actual values of some population parameters. First, we could collect a random sample and then use the information from the sample, namely the sample statistics, to estimate the population parameters. We will start off with estimating the population mean and then move on to estimate the population proportion. Estimate of population parameter is just one single value for the population parameter. If we want to estimate a population parameter, the point estimate would just be the corresponding sample statistic. The point estimate for population mean is sample mean. The point estimate for population standard deviation is sample standard deviation. The point estimate for population proportion is the sample proportion. This procedure is called point estimation. If we are using the sample mean to estimate the population mean, we could use the sample means obtained from different samples to perform this estimation. One question for you to consider is, how does sample mean obtained from sample of size 30 compare to the sample mean obtained from a sample of size 900? Both of these two sample means are point estimates of the same quantity, but they vary in terms of sample sizes. To compare different point estimates, we would use the standard errors of the estimates. The standard error of an estimate tells us how far this estimate is away from the truth, which is the population parameter. The standard error of the point estimate measures the precision of the estimate. We have discussed the expression of the standard errors in previous videos. This is an example of the point estimate for population average. The quantity of interest here is the number of cars sold annually. The sample size is 100. The sample average, X bar, is 75, and the population standard deviation, sigma, is 15. Note that 15 is the population standard deviation, not the sample standard deviation. For part A, the point estimate for the population mean is just the sample mean, which is 75, X bar 75. Part B asks why the sample average 75 is a good estimate for the population average. This is related with the sampling distribution of the sample mean we discussed previously. Because using CLT, central limit theorem, we know the sample mean is normally distributed with the center of the bell curve to be around the population mean and the spread of this bell curve to be population standard deviation scaled by the square root of sample size. So on average, the sample averages should all be clustered around the population mean. C asks for the precision of the sample mean. That is just the standard error of the sample mean that can be calculated using the formula we learned early on. That's going to be sigma over square root of n equals to 15 over square root of 100. That's going to be 1.5.